All right, the next concept we're talking about is multiplicity, and this will probably be a little bit new. We've talked about zeros before, we've talked about end behavior, but multiplicity is probably new. Basically, multiplicity just means it's the degree of a linear factor. Now, so far, all of our linear factors have been to the degree 1. But sometimes you get a 0 that's a 0 2 times or 3 times. And let's show you what this means. So if we did the same thing, if we're trying to find our zeros here on this example 12, I would first factor out an x. Notice how they all have an x term. So we're going to factor out our x. We're left with x squared plus 10x plus 25. And now what we're going to do is we're going to try to find our two numbers that multiply to 25 but add to 10. So we know 5 times 5 is 25 and 5 plus 5 is 10. So this would look like this, x plus 5 and x plus 5. So when we go to find our zeros right here, we would say, well, this x could be 0. So 0 is a 0. And then we'd say, okay, also negative 5 is a 0. So both of those are zeros. Now, when we say, let me do this a different way. Negative 5 over here. Okay, so when we say multiplicity, that means what is the degree? Now, this lovely binomial, notice how it is the same binomial, this x plus 5 and x plus 5. A lot of times people will write this different. They won't write it out twice. They will just say this is equal to x times x plus 5, and then they'll say squared. Since there's two of them, it's just multiplied to itself, they'll just square it. So if they write it like this, remember the multiplicity is just the degree of its factor. So right here, this negative 5 that we got from this linear factor is to the degree 2. So we just say that that one has multiplicity of 2. Okay, so negative 5 is our 0. It's a 0 twice. Okay, and 0 is a 0. Its multiplicity is, what's our degree here? This is tricky because we don't usually write the degree. Our degree is just 1. So it has multiplicity 1. So we've got our two zeros. 0 has multiplicity 1, and negative 5 has multiplicity 2. Let's try another one. They get a little easier as we go through here. So notice right here, what's my greatest common factor? Well, I see they all have x's. In fact, they've all got x squareds. And since I like to factor with my leading coefficient being a positive number, I'm going to factor out that negative right there. So I'm going to factor out a negative x squared. What do I multiply negative x squared to get x to the fourth? Well, x squared. I've got to multiply a negative x squared with a negative 6x right there to get that positive 6x to the third. And I'm going to multiply it by a positive 9 so that I've got a negative 9x squared when I distribute. All right, when I go to factor right here, again, we'll leave that negative x squared out to the front. What numbers multiply to 9 and add to negative 6? Well, negative 3 times negative 3 gives me a positive 9, but negative 3 plus negative 3 gives me that negative 6x. And again, most times people won't write it out twice. They're just going to say, okay, that was a factor twice, but they'll write it like this. All right, so we still have two zeros here. We've got our two linear. This one's not really linear, but we've got two factors right here. Okay, so 0, if we solve this, we get 0 is a factor, and its multiplicity is 2. So the multiplicity is 2 for 0. And then our other 0 is a positive 3. That one also has a multiplicity of 2. So we've got two zeros. They both have multiplicity of 2. That's how we add everything up to 4. Okay, so usually you'll have 4 zeros, but if they have multiplicity more than 1, then you'll have less than 4 zeros right there. All right, let's put this all together. We're going to show you what this means. Why is multiplicity so important? Well, it does something really cool to our graph. It actually causes our graph to bounce if we have an even numbers or multiplicity. So it's going to bounce at some zeros right there. If it's an odd multiplicity, like this 3 or like a 1, it will cross. It will cross the graph. So you just have to learn this, and we'll practice these enough that you'll have them down. But if it's an even multiplicity, that means that our picture bounces at that 0. If it's an odd multiplicity, our picture is going to cross at that 0. So let's look right here. at this nice, lovely equation, we've got 3 zeros because we've got our 3 linear factors. So we're just going to plug in our zeros. Again, if you're still struggling finding zeros, all you have to do is take that and set it equal to 0. That's what we mean by zeros. What gives me a 0? Well, if I just add 2 to both sides, x is equal to 2. So we'll say 2 is our 0. Our multiplicity, again, is just the degree of that 0. So it's degree 2. And then the effect, you're either going to say bounce or cross. Okay, so since my multiplicity here is 2, it's an even number, this graph is going to bounce at that 0. Okay. All right, let's look at this next one. We've got this 3x plus 7. If I want to solve this, 3x plus 7, some of you guys just see this. That's fantastic. You don't have to write these out. But I'm going to solve it. I'm going to say 3x is equal to negative 7 divide by 3. So my 0 here is negative 7/3. What is the multiplicity of this 0? Well, it is 3 right there, which is an odd number. So that means that at this 0, my function is going to cross the x-axis right there. Okay, last one. Let's do, oops, hold on. Okay, we are back. Okay, do I dare change the color now? All right, we're going to do this last one. We've got a 4x minus 3 and set that equals to 0. So add 3. 4x is equal to 3. Then we could divide by 4. So our x is equal to 3/4 right there. That is our 0. Its multiplicity, again, multiplicity is just the degree. So it's degree 2, which means since that's an even number, our graph is going to bounce at that 0. All right, in our next few videos, we're going to show you how to put this all together. We're going to graph these using our end behavior, our zeros, and our multiplicity. All right, tune into the next one.